We mentioned last month we wanted to try changing up a few things. The first one that I'm going to do is get rid of Meetup. Meetup.com at the moment they've increased their charges, so it's now $300 for 6 months. So there's a bunch of people getting off Meetup, and I am going to be one of them. So we're going to move to Numa. Is that what it's called? No, Luma. So I've got one started up just to try it out.
Excuse me, Matt.
Yeah.
Matt, are you aware that the Python Software Foundation will pay your Meetup fees for a Python user group?
Yeah, unfortunately, they've run out of grants.
No, you don't need to ask for a grant. There's a Python Meetup Pro network. I'm not sure if I've got all those words quite in the right order.
Okay. If you've got a link to that,
I can help you out with that, certainly.
Perfect, thank you. The last I looked into it, they asked me to apply for a grant, which was going to get approved, but yeah, they ran out of money for it. So if there's another way in, I'll happily take a look. I mean, that said, Luma looks pretty good. But if we can reduce the friction by just staying in Meetup, then we do so. Cool. So we're all paid up till February anyway, so we'll probably run them. Really run them both in conjunction, at least for a little while, unless this Meetup payment comes through. Sure, I've got awful hair, but that's okay. The next thing I wanted to talk about was PyCon. There was a bunch of us that went to PyCon AU in Australia here. It wasn't a huge focus on MicroPython this year, mostly because myself, Damien, and Andrew we were all busy and didn't put talks together. But there were some interesting stuff that was worth sharing. What was this guy's name? Edwin. So Edwin gave a really good talk. This is part of one of the education specialist tracks, talking about using microbits for Year 10 students, where he used it in an exam situation where these students had to use their own microbit to connect to hidden ones that were in the room and decipher codes, because it was a cryptography exam, and then unlock the code, figure out a puzzle, get to the next microbit, and so on. So there's a bunch of stages to it. To the culmination where there was one that started playing a Morse code beep that was buried underneath the teacher's desk. So it was a really cool way of using technology in an exam situation. And thanks, Kiwi PyCon is on in November. There's a MicroPython workshop. Good reminder, thanks. Right, the other ones that were worth talking about were just open source ones, and I think Damien really enjoyed these ones in particular because it was talking about sustainability of open source projects and how there's a massive maintenance burden once you've created these things. Right. And so I found this one in particular quite good. It was talking about how we can address that imbalance. Worth a watch. All the videos for all of the videos, I think, are online now. Almost all. Okay.
They're being uploaded still.
Yeah, right. Okay, cool. So Death of Consequences by Chris and the Sustaining Open Source Software by, what's his name? Justin. We're really good in those open source sustainability sort of modes. The lightning talks are always a good watch as well. In particular, I'll call out one that I particularly liked, which was actually, if you look at my top, this was the logo for PyCon this year, and they would play an animation of this before each of the talks, and it was animated and had some sounds playing along with it. And it turns out someone gave a lightning talk. The guy who created the animated logo gave a lightning talk at the end to talk about a hidden message that was built into that. Some of that audio that was being played, and it was to do with like old school tape playbacks from the ZX Spectrum days. So you could actually sample the audio from the talks and run it through a ZX Spectrum and get a program to play out of it. So well worth a watch. Yeah, it's pretty cool. What else do we have?
The escape room.
The escape room one was really good as well. So Tom Allen actually used to work at PI, the same company I did. He left many years ago to start these escape rooms that have been running in Melbourne for about a decade now. And so he talked about how that happened. They're using Python for a lot of the infrastructure there, and they're really interesting left of center sort of career, I guess. So look out for that one. Yep. In new hardware, we've got the baguette, which I've seen in a couple of locations now. The point of this weird looking ESP32 board is that you can plug it into a breadboard and have plenty of the breadboard still available and accessible. Pretty neat little board, I thought. There's a really interesting, humane mousetrap with MicroPython, so it actually emails you when it's caught a mouse. But it's got like a gate, and it talks about how to build the thing as well as actuate and send the notifications. So really interesting write-up. I'll share all that. Sorry, I missed the comment. Thanks. Cool. What else we got? I stumbled across this MicroPython ESC. So it's this is a brushless motor controller. Actually, it's brush and brushless motor controller. It's tiny and it's got like a little display on it, so you can see some parameters of the device, and it's running MicroPython. I don't know how hackable it is, but yeah, it looks really interesting. Quite affordable. Seems to have decent, like 50 amps is not terrible at all. So if you're into these brushless motor controls, this thing's looks really cool. There's a good guide here on how to get LVGL built with MicroPython for the Pico. Andrew and I have been chipping away at this problem for a while now as well, but this at least gives you a way to use what's currently out there. So that was pretty cool. There's another board that's come out, which is a Shrike, which I believe was an RP2040 as well as an FPGA. So if you're into that kind of thing, that board's available now. I'll share all these links at some point somehow. Yeah. And Olimex released another one of the 2350 boards, and they've broken out all the pins, so it's a neat one to have in the kit as well. And Salvatore released the MicroPython driver for these VFD displays. So if you like the old school retro look, there is another MicroPython driver that's kind of cool. I think that was all I had for the new hardware. Let me just check. I'll come to the PSOC in a second. Actually, I'll come to the PSOC now. There's trying to manage the chat window as well. Trip notification. Thanks. Interesting. I'll let everyone else read that. Infineon make the PSOC range of micros, and there's a few different iterations. We're up to the PSOC 6, and they're about to release the PSOC Edge. This is really noteworthy for MicroPython because they've also released a really large PR to give MicroPython support for the PSOC 6 range, and in particular a couple of their boards. And this is one of the more interesting boards. It's a small one we've got here. Let's see the thing. It's one that we've got here, if I can see. Yeah, cool. And this one's got, the PSOC's micro itself, of course. It's got JTAG, it's got accelerometer, I think it's got a magnetometer, it's got I2S, it's got Bluetooth, Wi-Fi, a whole bunch of stuff is jammed into this board, and it's $40 US. The especially nice thing about it is their PR for MicroPython, which is intending to add a whole new port to MicroPython. But that PR has got excellent support for this board, including Wi-Fi, including I can't remember what the name of it is, but they've got like AI support for this, Deepcraft Studio. So they've got like a separate PC-based system where you can build AI solutions and then deploy it to the device. And they've got MicroPython bindings to allow you to do that with this port.
Actually cloud-based.
As a cloud-based, is it? Okay.
You run it on a PC, it captures data, you send it
right,
to the
right.
cloud, and then
Cool.
download a binary.
Very nice. Yeah, it looks really interesting.
Yeah.
I was also just really impressed. They've gone a fair way to giving support for all of the peripherals on the board as well. So, yeah, I've been trying to help Damien review that PR. It's quite large. One of the problems we have, one of the difficulties we have is when someone contributes a port, because there's hundreds of files, it just takes a long time to review. And so I think Infineon must have submitted this, I think it was the second time, like in May. So we've been sitting on this for a while, just chipping away at it whenever we could. So if anyone's got a spare half hour, an hour to have a look at some MicroPython code, take a look at the PSOC 6 PR and just take a wander through it. They've got good documentation. It's reasonably well laid out. There's a few quirks to it. The way the build system is currently held together probably needs to change a little bit, but in general, it's a very good port. They've even gone like, because it was submitted before we had I2C target, they've actually got like an I2C slave and an alternative implementation, which we'll need to sort of figure out how to manage both of those. But yeah, they're looking for feedback because they're looking at expanding that port perhaps to their the new Edge chips. And those Edge chips look really interesting too. Tons of RAM designed around AI at the edge kind of applications, with Cortex M55s and all sorts of stuff on them. They're all the Edge stuff's all dual core. Bit hard to get hold of at the moment, but PSOC 6 is in good shape. So yeah, that was all I had to say about.
Wi-Fi Bluetooth on chip, or is it on board?
No, it's they've got a peripheral. In fact, they use the Murata chip that Damien's Hyperboards use. So yeah, I think they've got their own. The way Infineon works is they've got this thing called the Modbus Toolkit, which is kind of like their HAL for all of their hardware, and they've basically just built MicroPython over the top of that HAL, and I'm pretty sure their Wi-Fi comes in from that. So, yeah. If you, so I had a problem at work where we needed to, sorry, that was it for PSOC. If you've got any questions, happy to talk about that later. The next thing I wanted to quickly mention was that I had to diagnose a problem with one of our devices at work, and it required rebooting the system a number of times. So I've got like a power toggler now. So if you've got like a relay and a micro, this thing is really useful for doing this. I've had to do this a handful of times over my life. So I'm just letting you know that there is a GitHub now with some very simple code that allows you to run the same sorts of things with some configuration. So if you've got a similar need to do that, take a look at mine and expand it, and we'll try and make this a reusable system that we can.
What this thing?
Yeah. Okay. Yep. Everyone has the need at some point. Yeah. Yep. Okay. In terms of new hardware, I think this just slipped through last. I'll sit down in a second. Last month I received a WaveShare package right after the meetup. So there's a new P4 board. These are this is an ESP32 P4 from WaveShare. These come in a number of SKUs. I think we talked about these last time, but I finally got my hands on one. They come with, this one doesn't have it. This is a bare board, but they also come with Wi-Fi or Ethernet like built onto it. So this one's just the plain board with P4 and MIPI display and MIPI camera ports on the top. Pretty neat little board for, I think it's $12. It's ridiculous. I also got one of their matrix displays. This is RP2350, I think, from memory. Could be an RP2040, but it's an RP. Yeah, thanks. Tell me what it is. It's been a while since I looked at it. 2350, great. So they've got an accelerometer on board as well as an 8x8 LED matrix. Also cheap. I can't remember how much, but it was the cheapest of the lot. What else did I have? This one. Oh no, the knob. So this is a beautiful ESP32 S3 board. And actually the demo software on it's kind of cool. It's got a battery on it as well. I can't call the size of the battery, but it's running LVGL of some description, and it's a 1.8-inch display, and it's a pretty cool demo. The very nice thing about it is it's like anodized metal on a bearing, so the actual actuation of the rotary encoder is really nice. I can't remember how much they were, but $40 odd range from memory. Really pretty. If you've seen Volos Projects, who has a bunch of YouTube, or has a YouTube channel, he's done a project with one of those already. Pretty neat. And finally, yeah, they have a range of industrial boards, WaveShare do. This one's the S3, ESP32 S3 based with PoE. So you've got the network port and a bunch of digital I/O that's protected. And in fact, it's on a separate chip. Again, I've got a use in mind at work for that. So that's what that's about. And I think that's all I had for you. Any questions there? No? All good? Okay, good. Do you want to show off your project first, and we'll get to Joss? Yeah. I'll let you introduce yourself. You want to bring us the props or?
Everyone, my name is Puya. I'm a developer, been doing this for 10 plus years. About a year ago, started looking at MicroPython for work for a smallish project that wasn't too complicated. And so far the experience has been good. Wi-Fi, Bluetooth, communicate with cloud. It's a pool controller, so controlling lights, heater, and valves that go to a pool, and a couple of GPOs there for anything else that people control with their pools. I've got the product there, yeah, and it's still in prototype phase, but
move the camera if you like.
Yeah.
So it's still in prototype phase, but we're almost going into field trials soon. We've unveiled this last year in a public forum, so that's why I've got permission to show it here. But yeah,
Show the other side.
so yep, AquaFed has got a bunch of ports, and you're developing an app for this as well at the same time. So yeah, the whole firmware is written in MicroPython.
Cool.
Yeah. Just that. Yeah, that's it for me.
I should have mentioned too, I was going to do a dissection, I guess, or a bit of an explanation about the projects that I'm working on at work, but it'll have to hold off till next month.
Probably need to get permission.
There's a little bit of that, yeah. I will share the URLs too soon.
I made a foobar, got some egg on my face because I was looking at some tracing down the problem, then thought, okay, the ESP-Now documentation is missing something. I created a PR, and then Damien found out, oh, by the way, these parameters that you're adding don't actually exist, right? And I forgot to well, simply test it, and I mixed up some of the CircuitPython with MicroPython. Well, you know that also I've always been on the hunt for extracting code snippets from the documentation. So I was looking for something that would help me with that, because copying and pasting is, well, not something that is too good. So now I'm trying to figure out how to share my screen here. That should be this screen. Click share. So hopefully you can see my screen now. And so what I've done is I have looked at, well, I've already looked at doc test plugins and other things. And I always found them wanting, because they somehow, what they can do is, for instance, if you look at the documentation, right, they can take these little Python snippets that we have spread out through the documentation and extract them and run them in Python. Well, that's nice, but of course we want to validate whether they actually run on a chip. So what I've done is there's this, well, it's not quite, so I'm used to using PyTest, but the same thing goes for unit test as well, is where there's a thing called Sybil, right, which comes from the Monty Python series, right? There was manual first, right, and then Sybil came along. Sybil has a bunch of primitives for doing these things, right? Taking out RST files or Markdown files or anything, and then locating the sections that are either marked out as a code block or marked out as as a doc test snippet or other things. Right, so either with the triple chevrons in front, and then it checks that. So what I did is I added a bunch of functions to actually, well, then essentially extract that, run it in a file, and then use np remote run to run it on an attached board. So I can do that for the entire quick reference, right? And then what you'll see here is that it's now chunking along, right? Creating that, running the different scripts, right? Or the different snippets that are in there, right? And then as it goes along, it essentially confirms whether it's success or not, right? And clearly, right, in this case, I'm running ESP32. Well, I know that there's an X6 connected, right? So if I run Zephyr code here or PyBoard code, clearly it won't run. So there's still some stuff to do. But what I already found is that apart from, well, there's quite a large number of failures. Some of them are, well, okay, now it's just not finding a device, right? So there's code samples which run forever. There's code samples which, well, just stop halfway. And there's, well, simply things that have changed since the documentation was written. So the result of this is, I think the inspection is quite okay. Right? So, okay, now everything failed, right? So here, from my previous run from PyBoard, which I ran when the PyBoard was connected, right, you can actually go, right, this is a sample of a doc test, where actually there are a few things that are checking out, right? So, and there are some tests, well, that might not be checking out, right? So in this case, servo1.angle returns something. Well, depends on if I have a servo connected and what it is, right? So it can also check whether the outputs are there. There's some markup that also allows you to skip tests, right? If for instance, you run a random function. And I must say that, well, my primary intent was, okay, let's scrape all the documentation and make sure that I can run that through in my stubber testing, which is currently the repo that you're seeing as well. I also found that, well, actually, there are some logic errors in the test, right? So what I want to try out there is I could further develop this into a PR, right, which we can run as part of CI, which could either run the things that we can run in a Unix test, right? Because there's also a conditional where actually we can run logic. So only run this test if the platform is ESP32. Only run this test if that, right? That will require some additional markup to be entered in the RST files, right? But that's quite simple, right? To be honest, right? That's adding a RST dot if statement in there, which in the results, right, the rendering in HTML and PDF, right, are just identical. So the question then for feedback is, right, does this make sense, right? And either I hear nothing.
Sorry, yeah, wasn't sure if you finished. It seems to make sense, yeah, to me.
And I think the screen, did you see my screen or not? Because I can't see.
You're watching the screen, yes.
Okay.
No, it makes good sense. Yeah, I agree with Stuart. Yeah. Yep.
And then for me, the other question is unit test or PyTest?
Yeah, good question.
For this implementation, actually, it really doesn't matter because it's literally changing this .pytest for unit test.
Yep.
Right. So essentially what Sybil is a test collector, right? It collects tests and areas, and then it runs them through PyTest. That's why you get this nice navigation, right? Also where you actually end up in the actual test, so that and this is an example of, for instance, a test that needs to be skipped, because it runs a while true, right? And that kind of would stall the test. Clearly, we could do some additional parsing to make sure that if a test contains a while true, that we change that for while in range or something. Right, and otherwise we could essentially just use Python syntax here, right? If we need to import something and say, okay, if this platform is there, then done. Yeah, indeed. Thanks for sharing the Sybil. It's not a large framework actually. So yeah. Okay. So if you like it, then I'll create a draft PR so that you can see some of the work that I've done, and then, well, let's make it better. Part of that was AI generated, right? So there's spaghetti code still in there that needs to be bashed into shape. Okay, that was it for me.
That looks really cool. Looks really interesting. Yeah, I mentioned MakeDocs before, which I've been using for purely documentation stuff, but it's useful to extract inline documentation into a really nice looking output. I found it a little easier to use than Sphinx and a little less friction, partially because it uses Markdown rather than RST. So
I prefer Markdown for simplicity, but I must say that, right, even with things like Mermaid, there are still things that you can do in RST that I found hard to translate to Markdown.
Yeah, I think that's true. It's just we get very few contributions to Sphinx documentation, and part of that I think is just the barrier to entry. So
I agree, right? And I didn't show that, but what I've been using for that is that there's a Sphinx auto build, which essentially every time that you which I now run, because getting a preview is hard, right? And all the preview things miss out on something. If there's a package Sphinx auto build, you run it, it launches an HTML page, right? And you can just view it. If you press save, it runs on everything, and it is refreshed on your screen. You need a large screen, right? But that's, well, we need that anyway.
Sure. Yeah, I use a similar thing, but it's in a Docker container, so you don't even need to install it.
Yeah, you and Docker, yeah.
Of course. Yeah.
Makes sense. Okay.
The Sybil looks worthwhile. I'm going to take a look at it. Looks great. Did anyone have